Hello students, today we are going to discuss about Kepler's law. Actually, in previous video, I told you about Kepler's and his law. Actually, Kepler, that means Johannes Kepler, was the first man who introduced the mathematical interpretation about planetary motion between the Earth and the other planets. But before study about Kepler's law, actually Kepler's gave three laws of planetary motion. First is known as law of orbit, second one is law of area, and third one is law of time period. Actually, today we are going to discuss discussing about the first law, that is law of orbit only. But before Kepler's this law, we discussed some facts, some things. Like, actually there are three closed curve two-dimensional figure. And we should understand which figure is this. Now let's see on the board. Actually, we have three curve closed two-dimensional figure. These are first circle, we well know about circle. Second one is ellipse. And third one is parabola. These are the two-dimensional curve figure. That is circle, ellipse. Ellipse, that means a shape of just an egg, oval shape, and parabola is just like a shape of parabol, that is parabola. That means in both the ends have the same curve, but ellipse have a different, and that is curve. The axial line inside the curve, which just touch their circumference, are known as diameters, and the intersecting of these lines is called center. But in the case of ellipse and parabola, the larger axial line is called major axis. That is called major axis. And the vertical axial line is known as minor axis. And their centers is called, and their intersecting points called centers. Now, the half part of this section, that means diameter, half of the diameter in circle is called radius. But in the case of ellipse and parabola, half part of its vertical axial line is known as minor axis, semi-minor axis, denoted by B. And the horizontal half that is called radius, and both are equal in circle. But in ellipse and parabola, the horizontal axial line, half of the horizontal axial line is known as semi-minor axis and denoted by A. And we can say both these parts are equal in the case of circle, but in ellipse and parabola they are different. So we can say that if ellipse in a parabola, if the semi-minor axis is equal to semi-major axis, then an ellipse and parabola becomes a circle. This is the main difference between these three closed figure, these three two-dimensional closed curve figure. Actually, the area of the circle is pi r into r, but the area of the ellipse is pi a into b. Actually, that's a difference. That's a difference. And that ellipse have two focus. That ellipse have two focus. That means the first half part of the major axis, that means we can say the horizontal line, first half, the center of this semi major axis called focus 1, F1, that is called F1, and the center of and the middle point of this part of semi major axis is denoted by F2. So we can say that ellipse or parabola have two focus, that is F1 and F2, and the average distance of any point on its circumference from F1 and F2 is fixed. That means if F1 have a distance A1 and that is A2, then A1 is equal to A2, even the body is here. That means A1, A2. In every point, if a planet moves around its circumference, then from F1 and F2, their mean distance is always fixed. Clear? Now, let's start the first law of orbit, the Kepler's first law. Johannes Kepler was the first man, I told you. Johannes Kepler was the first man who introduced this planetary law on the basis of his mathematical interpretation. According to law of orbit, or according to Kepler's first law, a statement is every planet moves around the sun in an elliptical orbit. Every planet moves around the sun in an elliptical orbit. This is the planet, elliptical orbit, and the sun is situated one of its focus. Actually, they have two focus, F1 and F2, and sun is lies anywhere. We can put it here or we can put here. This is the sun. This is the position of sun. So we can say, according to Kepler's first law, every planet moves around the sun in an elliptical orbit, and sun is situated one of its foci. Actually, this is the law. This is the orbit, that is the elliptical path, and sun is situated one out of its focus, and P is the planet moves around its elliptical path. Then actually, what is the conclusion of this law? Conclusion of this law, that means in the revolutions of the planet, एक समय ऐसा होगा जब प्लैनेट सन के नजदीक होंगे, दैट मीन द पोजीशन P1, और एक समय ऐसा भी होगा जब प्लैनेट सन से दूर होंगे, दैट इज द पोजीशन ऑफ P2. When you know that when the planet is nearer from the sun, that is the condition. When the planet is nearer from the sun, then that situation, that means P1 is called perihelion. Perihelian. That is the condition of perihelion. The position on the elliptical path when the planet is nearer from the sun is known as perihelion. And the position in where the planet is farther from the sun is known as aphelion. 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 Actually, these are the two conditions. Pehla conditions jo hai, that means the planet is nearer from the sun, is the condition for our earth is the summer season, and the aphelion conditions is the winter season for our earth. So these are the two conclusions, that when the planet around its rotation, revolutions, we can say revolution, when it is nearer from the sun, then that condition is called perihelion, and when it is farther from the sun, that's a farther from the sun, then that condition is called aphelion. And the first law of Kepler, that is law of orbit, states that every planet, listen carefully, every planet moves around the sun in an elliptical orbit, and sun is situated one of its foci. Now for today, thank you.